Hi everybody, I'm here to explain to you how to measure current, voltage, and understand Ohm's law. Here you can see me setting up the electric circuit with a couple of cables and different resistors with different values to simulate this experiment of getting voltages and currents across this circuit. Um, what I'm doing is basically setting up the resistors in series, putting the voltage source on the left. I'm gonna show you like pretty soon how this circuit is on the board.
Well, so here I have like the circuit with the value of each resistor. In this case is 10 ohms, 15 ohms and 20 ohms. I got my resistor 1, resistor 2 and resistor 3 and the voltage source. I was just finishing to put everything in here. As you can see, here is the voltage, resistor 1, resistor 2, resistor 3. And now I'm gonna turn on the power. I put 9 volts and I'm reading right now through the resistor one is 1.74 volts. As you can see, the configuration is exactly as it's supposed to be. And then I'm gonna try to measure the next voltage in the next resistor. Okay, now I just changed the cables or the wires to measure the volt resistor 2, as we can see, and I have a reading of 2.96 voltages. So now I gotta write it down on the whiteboard. Well, now I just change it again to this position, and we got 3.70 something, 76. I would say 74 because it was moving like around that number. So yeah, 3.74. Well, now here that I have all my measured voltages, now I'm gonna do is show you how I measure the current. What I did is here break the circuit between resistor 2 and 3. We just put the right like leg of the resistor 3 more like lower so we can put this black wire to measure in the same line of the resistor 3. So I don't know if you can see it. Let me take off this one. So you can see they're in the same line. So here we put the black one, the red one, and we'll be able to get a reading of 0.19 amps. That is the current resistors because they are all in series. Alright, after we measure the current, obviously to measure the current we gotta change the position of this one's current here, voltage here. Never changes, just to make sure. And now, as we can see here, I got like my little table of all the measure data that we get from this electric circuit. I'm gonna put a little title, measure. Yeah, and now I'm gonna show you guys how you can use the Ohm's law to calculate all this data. It will not be exactly the same, but if we got like almost exact number, we can say that we did a good job in the electric circuit using the multimeters and plugging and unplugging everything. So one of the things that I'm gonna do to basically show that I got the right current is to calculate the current through current's law. What you can do is basically pick one of these resistors, or another choice that you can do is add all these three resistors. They're all in series, so you can add them as how they are. 10 plus 15 is 25, and this is 45 total resistance. And the voltage source, that is the total voltage, you can put that in this equation, V equal IR. You clear the I, V over R. Basically, if you put on your calculator or you do it on your head, you will get 0.2. amps. So yeah, it's pretty similar, because the measure one that we got, it was 0.19. So we can show with this equation and with these values that the current through the whole resistor is 0.2 if we want to calculate it like this, or 0.19 if we want to use the electric circuit that we just did. Also, you can play with these things of Ohm's law with any value that you have. Yeah, for example, here I put calculated V equal IR. So my I calculator was 0.02, and I'm trying to find my B1. But I already know that my R1 is 10 ohms. So what I'm gonna do is put B1 equal to I1 multiplied by R1. So we just multiply 0.2 by 10. If you do that mentally, or you use the calculator, it will give you obviously 2, just to make sure. So the voltage that you get is 2 in the calculated, but the voltage that I have measuring in the electrical circuit was 1.74. This could change a little bit. Now to basically prove that our current is right, that we already did, it was this first equation that it gave us 0.2 amps, and in here it gave us 0.19. Our current is good. Now we're gonna measure our voltage. So one of the laws that says that basically if we take all these voltages of all these resistors and we add them, it will have to be equal to this, or summatory of all voltage is equal to 0. So basically, to prove that this is good, we just gotta add every voltage, and we're gonna see how much we get. So in this case, we got 8.42. We got 8.42 measure. And this is the voltage source, so we can say that yeah, it is. I think we did a good job doing this electric circuit. Obviously there are gonna be some decimals that we lose, maybe it's for faulty equipment or for things like that, but basically 8.42 is pretty close to 9, so we can be sure that our data is right. Yeah, also another thing that I can show you is the voltage loop. This is like a plus or bonus. Basically what you can do is go counterclockwise. I wanna say that this is the direction of my resistor or my current. So if we add all these ones, should be equal to this. To this I mean to 0, because voltages in a loop all have to add to 0. So this is plus, this is plus, this is plus, and this is minus. Sorry, I did a little mistake. I mean, it's not a mistake, it will still work, but the thing is, it's the first sign that we saw. So basically, if I start from here, is minus, 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 and plus. So basically it will be the same thing that I did, just in a more formal way, if I can like describe it like that. I'm gonna pause the video. So here we got our little voltage loop of the resistors, and at the end we got the plus 9. The result of this, basically, if it is equal to 0, we did it right, but if it is pretty close, I think it still works. So I'm gonna calculate that right now. It should be the same. I have 0.58. It's not equal to 0, but it is basically saying that we are pretty close to the result. So yeah, this is how we get the voltage, current in a measured way and in a calculated way We know how to use Ohm's law, so thank you very much. I'm gonna erase this.